Example 4. We want to sketch the region enclosed between the lines y is equals to x and y is equals to x times 4 minus x. So if I get the number plane out, okay, so say we've got the x-axis here and the y-axis here, right? Labeling the axes, I've got y, x, origin. So y is equals to x times 4 minus x is going to be the concave down parabola with x-intercepts at 0 and at 4. So if I sketch this in, it's going to look like this, right? Roughly speaking. So this is of course not drawn to scale, but this is x equals to 0, this is x equals to 4. So what's also going to be important is that we identify where the vertex is. So we know that the x-intercepts are at 0 and 4, so the axis of symmetry in this case is going to be x equals to 2. Which means that this point here, when x equals to 2, our y value is given by 2 times 4 minus 2, so the y value of the vertex is at 4. So now if I draw on y is equals to x, then we know that relatively speaking, y is equals to x is going to look like this. And of course, like I said previously, this is not drawn to scale. Okay, so this is y equals to x, and this is y is equals to x times 4 minus x. But at least with this, we're now able to sketch the region that's enclosed between the two curves, and this is the region that we seek. Part 2 then wants us to hence find the area. Now to find the area enclosed between two curves, we just integrate from a to b of the top curve minus the bottom curve with respect to x. So in this case, what that means is that we need to identify where the points of intersection are, or at least so far as we know the x values. So I'm going to solve simultaneously between the two equations to get our intersection points. So solving simultaneously, we are going to get x is equals to 4x minus x squared. And if I move everything on the right to the left, we get x squared. 4x goes over, it becomes minus 4x. X minus 4x is going to be minus 3x is equals to 0. Factorizing the x out, and this tells us that we've got two solutions, one at x equals to 0 and one at x equals to 3. We already knew that the two curves intersect at x equals to 0. Now we know that the second intersection point here has x value 3. So if we're seeking the area in this case is going to be integral from 0 to 3 of the top curve. The top curve is the parabola, x times 4 minus x, so that's going to be 4x minus x squared, minus the bottom curve, which is y is equals to x dx. So this is the top curve minus the bottom curve, and we're integrating from 0 to 3, and that's going to give us the area that is enclosed between the two curves. So if I simplify the expression before we integrate, we've got 3x minus x squared, and if we integrate, we get 3 on 2, x squared minus x cubed on 3, and our limits goes from 0 to 3. So substituting 3 into the expression, we're left with 3 on 2 times 9, which is 27 on 2, minus 3 cubed on 3, which is 9. Sub 0 in and everything becomes 0, so we don't need to worry about it. And taking 27 on 2 minus 9, we're going to be left with 9 on 2 units squared. So that's what we have for example 4.